Hello everyone, welcome to SPEC eLearn, the online learning channel dedicated to chemical engineers. Interview questions, pumps, part 2. I would appreciate if you subscribe to the channel, which is striving hard to deliver valuable knowledge content for your career progress. So subscribe now before you forget. For every question, you are given 20 seconds to think about your answer. Then the answer will appear. Check your answer is correct. Pumps Part 2 consists of 5 questions. Question number 6. What is best efficiency point for a centrifugal pump? Use the pump characteristics to explain your answer. Your time starts now. Your time is up. The answer. Best efficiency point BEP is a measure of optimum energy conversion. When sizing and selecting centrifugal pump for a given application, the pump efficiency or design should be taken into consideration. The efficiency expressed in percentage represent a unit of measure describing the change of centrifugal force expressed as the velocity of the fluid into pressure energy. BEP is the flow rate at which the flow discharge angle matches with the blade or vane outlet angle. As the flow rate changes, the discharge angle of the flow also changes, but the blade outlet angle remains the same. The BEP is the point on the curve where the change of velocity energy into pressure energy at a given capacity is optimum. That is to say, the point where the pump is most efficient. Any point away on the left side of the BEP, the pump can get into cavitation as well as overheating and recirculation. Any point on the right of BEP, the pump is likely to experience maintenance issues. This figure illustrates the efficiency and head versus flow characteristics of a centrifugal pump. The pump efficiency is a function of flow through the pump. When the flow is zero, that is, when the discharge valve is closed, efficiency is zero. As the flow is increased by opening the delivery valve, efficiency increases until it reaches about 85%. This corresponds to about 20 cubic meter per hour. Thereafter, as the flow is further increased, the velocity inside the pump increases, but the loss also correspondingly increases. Hence, the efficiency starts declining. The point where the maximum efficiency line intersects the head capacity curve is the best efficiency point, as shown in this figure. Why does the efficiency change with flow rate? The larger the flow rate, the higher the turbulence, the higher the head losses, and the lower the efficiency. Impeller design is a primary factor that determines the flow rate at which the BEP occurs. Question number 7. Which pump delivers pulsating flow during running? What's the reason for the flow variations? How is the flow variation minimized in the industries? Your time starts now. Your time is up. The answer. Delivery from the positive displacement pump, such as reciprocating pumps, is not continuous and occurs only during the discharge stroke of the pump. There will be no flow into the delivery pipe during the rest of the cyclical pumping process. This results in flow variation in the suction and discharge piping of the reciprocating pumps. This intermittent and cyclical pumping action produces sinusoidal pattern of fluid pressure and speed, fluctuating around the average pressure and speed of the system. The flow variation can be studied by monitoring the velocity of the fluid in the piping over the crank angle. The figure shown illustrates the flow pattern in a single head pump versus the crank angle. Vibration may be a serious problem with reciprocating pumps because of this intermittent nature of discharge. In general, the problems are compensated by using two or more cylinders not working in phase with each other so as to smoothen out the flow into the delivery system. By having multiple plungers in the design and spacing the delivery of the plunger at different crank angle, flow from reciprocating pump can be smoothened out and flow variation can be minimized. Pumps are normally configured in triplex, quintuplex, and septuplex designs so as to reduce flow variation and vibration that is associated with the single plunger pumps. Shown in this figure is a triplex plunger type diaphragm pumps. Observe there are three pump heads available to take care of the pulsating flow. This figure illustrates how the oscillating discharge flow that exists in a simplex and duplex reciprocating pumps has been reduced considerably and more smoothened flow discharge has been achieved in a triplex pump. Installing pulsation dampeners at the discharge side of the pumps can also bring the pulsation problem under control. Pulsation dampeners absorb the energy from the pulse wave created by the positive displacement, much like a shock absorber on a vehicle. Absorbing those pulse waves protect the pipe wells and supports and system components from pressure and excess movement. Question number 8. What is the difference between single-stage centrifugal pump and multi-stage centrifugal pump? In which application multi-stage pump is selected? Your time starts now. Your time is up. The answer. Single-stage centrifugal pump is one in which only one impeller is mounted on the shaft. Multi-stage pump is a pump in which the fluid flows through several impellers mounted on the same shaft in series. The head of a single-stage pump is largely governed by the type of impeller and the circumferential speed. Thus, the usual design variables for varying the head produced per impeller stage are rotational speed and diameter of the impeller. In certain situations, the impeller rotational speed cannot be increased due to other operating conditions. A large impeller diameter will lead to very low specific speed, resulting in low efficiencies with high absorbed power and unacceptable economics. How do you then increase the head of the pump for high pressure applications? Fitting several impellers in series will be an economic option of increasing the head. If the number of stages are increased in the same pump at the same speed, the flow will remain the same, but the head will increase proportionally to the number of stages. Each stage develops an additional pressure rise. This figure illustrates a three-stage centrifugal pump at constant speed. What are the services that need multi-stage centrifugal pumps? Multi-stage pumps are selected for pumping applications where a very large discharge pressure is required. Examples of multi-stage pump applications include boiler feedwater pumps where discharge pressures up to 100 bars may be required depending upon the pressure of steam generated in the boiler. Question number 9. What is pump efficiency? What are the factors that contribute to the pump efficiency? How does it impact the pumping cost? Your time starts now. Your time is up. The answer. Pump efficiency is a ratio of the liquid horsepower delivered to the pump to the brake horsepower delivered to the pump shaft. Simply speaking, pump efficiency is the water horsepower to the brake horsepower. The overall efficiency of a pump is the product of three individual efficiencies. 1. Hydraulic efficiency. 2. Volumetric efficiency. 3. Mechanical efficiency. Hydraulic efficiency is useful hydrodynamic energy in the form of fluid and is a reflection of how the velocity energy is converted into pressure energy at a given capacity. Hydraulic efficiency includes liquid friction and other losses in the impeller and volute. Hydraulic efficiency is expressed as the pump's total head divided by Euler's head. The hydraulic efficiency is the single largest factor that contributes to the overall efficiency of the pump. Hydraulic efficiency for small pumps is in the range of 50 to 70%, whereas for large pump it is in the range of 75 to 90%. Volumetric efficiency. It is the ratio of the actual flow rate the pump delivers to the theoretical flow rate. The theoretical flow rate does not take into account the internal leakages, that is vein clearances, and leakages through wear rings and balancing holes. Volumetric efficiency is expressed as actual flow rate at pump discharge nozzle to the total flow rate passing through the impeller. Mechanical efficiency. Mechanical efficiency includes losses in bearings, stuffing bars, and mechanical seals. Mechanical efficiency is expressed as the ratio of power delivered by the impeller to the liquid to the mechanical power input to the pump shaft. The overall efficiency is the product of the three efficiencies we discussed just now. That is the product of hydraulic efficiency, volumetric efficiency, and mechanical efficiency. How does the efficiency affect the pumping cost? A pump with lower efficiency will consume more power for delivering the liquid for the same operating flow and head than a pump with higher efficiency. Hence, the cost of pumping or the operating expenses of the pump will increase. Hence, while selecting the pump, the efficiency of the pump being selected should be given due consideration. It is a good practice to examine several performance charts at different speeds to see if one model satisfies the requirements more efficiently than other. Whenever possible, the lowest pump speed should be selected, as this will minimize the wear and tear on the rotating parts. Question number 10. What happens when the discharge valve of a running pump is closed in A centrifugal pump, B reciprocating pump? Your time starts now. Your time is up. The answer. In a centrifugal pump, as the discharge valve is closed, the delivery flow will get reduced to zero and the head will increase to a value that corresponds to the shut-off head, which is the maximum head the pump can develop. Though the pump does not face any problem momentarily, continued operation with the discharge valve closed will lead to liquid recirculation within the pump. Both suction recirculation and discharge recirculation will occur, which will be detrimental to the pump in the long run. Reciprocating pump is a positive displacement pump. When the discharge valve is closed, when the pump is running, there is no outlet for the fluid being delivered to the discharge line. The pump will continue to discharge into the enclosed space formed between the discharge valve and the pump. The pressure will continue to rise and will lead to serious consequences, resulting in pump or piping system damage, and liquid can escape to the atmosphere. This is the reason why positive displacement pumps is not started with the discharge valve closed. As a protection, reciprocating pumps are fitted with a safety valve immediately on the discharge line to take care of any accidental closure of the discharge valve. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching.